Hi, this is Mr. Moss, and in this video, we're going to be learning about subtracting multi-digit numbers. You know me, I love to show you multiple ways to get the answer. So today we're going to be looking at two different strategies. The first strategy we're going to work on is the standard algorithm. It also is called the traditional method. And just like the standard algorithm or traditional method for addition, this is the way that so many of us learned how to add numbers, to subtract numbers growing up. It's been taught all over across the world. This is how we all grew up doing it. However, just like with addition, I'm going to show you one change that uh, we make when we teach kids how to use this strategy nowadays. So to start off, again, I'm always going from right to left, just like we did growing up here. 1 minus 0 equals 0. 5 minus 7, wait, I can't do 5 minus 7. By the way, a common mistake that students make if they're having a hard time with subtraction is to invert numbers when they can't subtract. So let me grab a pencil right here just to show you some examples of what a common mistake is. Some kids might continue to go on here and do, okay, 7 minus 5 equals 2, 2 minus 1 equals 1, 4 minus 7, I can't do that. 7 minus 4 is 3, and 3 minus 2 equals 1. That's a really common answer that I might get from a student. It's wrong, of course. But just to be aware, if you're a grown up watching this video, or even if you're a student watching this video, I can't flip flop these. I can't say 7 minus 5 equals 2. I can't say 7 minus 4 equals 3. I have to go in the order in which the numbers are written. So let me take this away. Let me go back to the example I was doing. I can't do 5 minus 7, so I need to take something from this too. Now, if you're like me, you grew up learning that the term was borrowing. We're going to borrow from this too in order to make this 15. Well, again, nowadays we really try to avoid using the word borrowing when we're talking about subtraction for the simple reason that, again, it's a cute sounding word. Hey, we're going to go next door, we're going to borrow that. But really, that's not accurate. We're not returning anything. We want to use clear and direct language. And that's why, yet again, we're going to use the term regrouping. Sometimes I'll call this trading, and you'll understand why in a moment, but I really prefer the term regrouping. So I can't do 5 minus 7, so I need to regroup. This 2 is going to become a 1. Now, again, if you were like me, sometimes you may have learned, again, let me switch to my pencil. You may have learned, oh, if we're turning this into 15, I can just kind of sneak a 1 in there and call that 15. I want to keep things as clear for students as possible. So I tell them, cross it out fully and rewrite the number 15. So now it's 15 minus 7. All right. So got 8. And now 1 minus 1 equals 0. Here I am again. I can't do 4 minus 7, so I need to regroup. That 3 becomes a 2. That 4 becomes 14. We've taken 10 from here, so we're able to add the 10 right here. So 14 minus 7 equals 7. 2 minus 2 equals 0. I don't have to put a 0 here because we don't start numbers with a 0. My answer is 7,080. All right, so that's the standard algorithm. It's what so many of us grew up doing. Then we get to the trade first method. Now, I'm going to give you a kind of a spoiler alert. If you looked at this without watching how I solved this, you would look at it and say that is the exact same thing that we just did. And when we're done, they're going to look almost identical. And we're going to go back and we're going to talk a bit about what makes them different, but you'll probably see. All right, can I do 1 minus 0? I can. Okay, so I'm set there. 5 minus 7, I can't do. I need to regroup. That 2 becomes a 1. I'm taking away a 10 from there. That makes this 15. 15 minus 7, yep, I can do that. 1 minus 1, yep, I can do that. 4 minus 7, I can't do. No. So 3 becomes a 2. 4 becomes 14. 14 minus 7, yep, okay, I can do that. 2 minus 2, I can do that. Okay, I've done all my trading. I've done all my regrouping. Now, time to go do the subtraction now. All right. So 1 minus 0 equals 1. 15 minus 7 equals 8. 1 minus 1, that's 0. 14 minus 7 equals 7. 2 minus 2 equals nothing. 7,081. And when you look at the two of these side by side, they look almost identical. I mean, all the spots where I've done my regrouping, it's almost exactly the same. In fact, the only difference is in the trade first method. I put a bunch of these check marks here. Well, let's look and see what I did and why I did it that way. If we go back to the standard algorithm, you'll notice that I'm really kind of bouncing around as I'm working on this. So I'm going to go over the work that I just did, but I'm going to kind of trace it out with my pen. I don't know how well it's going to show up here. Let's do actually a slightly more bright color. All right, so I did 1 minus 0 equals 0. 5 minus 7 I can't do, so I had to take that 1, make this 15. 15 minus 7 equals 8. 1 minus 1 equals 0. 4 minus 7 I can't do, so I had to regroup. 2 makes the 3 goes to a 2, and that makes it 14. 14 minus 7 equals 7. 2 minus 2 equals 0. You can see I'm kind of bouncing all around here, and I'm continually switching from regrouping to my subtraction. And for a lot of kids, that's totally fine. But in the trade first method, you do all your trading, all of your regrouping first, hence why it's trade first. So I do my 1 minus 0. I ask, can I do 1 minus 0? Yes, I can. And then I'm going to go on 5 minus 7. No, I can't do that. Okay. So the 2 becomes a 1. That makes 15. 15 minus 7. Yep, I could do that. Okay. And I have 1 minus 1 equals 0. 4 minus 7 I can't do, so that's going to become a 2. 14. 14 minus 7 I can do. 2 minus 2 I can do. And then after I've done all of my trading first, then I'm going to come back, and that's when I'm going to really solve it. 1 minus 0 equals 1. 15 minus 7 equals 8. 1 minus 1 equals 0. 14 minus 7 equals 7. 2 minus 2 equals nothing. So this allows me to kind of get organized in my thinking process. It allows me to recognize I'm going to do all of my regrouping first, then I'm going to do all of the subtracting after. And for some kids, not having to switch back and forth between regrouping and subtracting really helps them out. It helps them to better understand what they're actually doing here. Every student is different. And when I showed this strategy to students, I'd say it was a 50-50 split who preferred trade first and who preferred the standard algorithm. So everyone's a little different. Let me finish by doing just one more example with you. These are the same problems, and you'll see how much they're going to end up looking alike one another when we go to subtract. So starting off, I have 8 minus 9. I can't do that. So 2 becomes a 1. 8 becomes 18. 18 minus 9 is 9. 1 minus 9, I certainly can't do that. 8 becomes a 7. That 1 becomes 11. Again, we're not just sneaking that 1 in the side there. We cross it out and we rewrite it. We want to keep everything nice and clear. 11 minus 9 is 2. 7 minus 2 is 5. 3 minus 7, can't do it. So 9 becomes an 8. 3 becomes 13. 13 minus 7 equals 6. 8 minus 6, yep, I can do that. That's 2. 4 minus 2 is 2, and my answer is 226,529. If I do the trade first method, it's going to look almost exactly the same. 8 minus 9 I can't do, so I'm going to do my trading first. 2 becomes a 1. 8 becomes 18. 18 minus 9, yep, I can do that. 1 minus 9, can't do it. 8 becomes a 7. 1 becomes 11. 11 minus 9, sure, I've got a larger number up top. I'm all set. 7 minus 2, yep, can do that. 3 minus 7, no. 9 becomes an 8. 3 becomes 13. 13 minus 7, yep, that'll work. 8 minus 6, yep, good to go. 4 minus 2, all set there. And now I'm going to do my actual subtraction. So 18 minus 9 is 9. 11 minus 9, that's 2. 7 minus 2 is 5. 13 minus 7, I can do. That's 6. 8 minus 6 equals 2. 4 minus 2 equals 226,529. So both of these strategies, you can see what I mean. They look almost exactly the same when you're done, except for those check marks. In fact, if I'm looking at a student's work, if they forget to bother to put the check marks there, I have no way of knowing which strategy they used unless I ask them. But as much as these strategies look the same, they act very differently. And for some kids, it can really make all the difference in the world between a subtraction process that's really challenging for them and one that makes sense. So families, if you're watching this, let your students decide which one makes the most sense for them. Students, if you're watching this, go with the one you're comfortable with. Again, my rule is always I want you to be familiar with both strategies so that you can make an informed decision. But once you have one that you really prefer, as long as you're familiar with both, you'll be welcome to use the one that makes the most sense for you. This has been Mr. Moss working with you on subtracting multi-digit numbers, and I really hope this was a helpful guide for you. Have a great day.